Hi class, it's Mr. Trez, and this video is going to be about vertical translations, horizontal translations, and multiple translations. So what I want to do is just make a video going through the key concepts, and hopefully this will give us a little better understanding. So first, parent function of a quadratic function. A parent function is the simplest function of a family of functions. The graph of f of x equals x squared represents the parent graph of the quadratic functions. A transformation is a movement of a graph on the coordinate plane, and a translation is a transformation where a figure is slid from one position to another without being turned. So let's take a look at vertical translations. So the graph of f of x equals x squared represents the parent graph of a quadratic function. When a constant k is added to the quadratic function, the result is a vertical translation. For example, g of x equals x squared plus k. If k is greater than 0, it's translated up. If k is less than 0, it is translated down. So let's take a look at our example. Here we have f of x equals x squared, our parent function. This is represented by the black parabola on the graph. So the parent function, this is where it starts. G of x equals x squared plus 2. So here is x squared, our parent function, and then it's plus 2. So it started here, and then it translated plus 2, so it went 2 units up. Okay, so plus 2, that is the k, okay, in the function. H of x, the blue parabola, is x squared, our parent function, minus 2. So now, since k is minus 2, that means it translated 2 units down. Okay, next we have our horizontal translations. So the graph of f of x represents the parent graph of the quadratic function. The graph of g of x equals parentheses x minus h squared is the graph of f of x equals x squared, the parent function, translated horizontally. So now we're going right or left. If h is greater than 0, we're going to go to the right. If h is less than 0, we're going to move to the left. Okay, so let's take a look at our example. So f of x equals x squared. That's our parent function. It all starts there, and that's represented by the black parabola on the graph. So next we have g of x equals x minus 2 squared. So our parent function minus positive 2. So now, since it's positive, this moved 2 units to the right. Now this is where it gets a little bit tricky, because a common mistake is to see x minus 2 and say, oh, okay, since it's minus 2, this looks like negative 2, and negative we would move to the left. But in this case, the red graph, it moved to the right. So why is that? Well, the key is to look at this function right here. So we have g of x equals parentheses x minus h squared. So I'm going to bring it down right here. So it has to be x minus h squared. This is like the standard form. So x minus, and what number do I have to put in right here? This way it looks just like that. Well, I can't put in a negative 2, so I have to put in a positive 2. Okay? So this is really x minus positive 2, which means it's going to move 2 units to the right. Okay, next let's take a look at in blue. So h of x equals x plus 2 squared. So it's our parent function, and then x plus 2 squared. This blue parabola moved 2 units to the left. So again, this is where it could get a little bit tricky. So let's take a look. And again, we have x minus h squared. So we want to be x plus 2 squared. So x minus, so instead of like minus h, what do I have to put in right here so it becomes positive 2? Well, anytime we subtract a negative, that is the same thing as adding a positive. Okay, so it is helpful to see this plus 2 as minus negative 2. Okay, so this is really a negative, and that's why we are moving 2 units to the left. Okay, and finally we have our multiple translations. When constants, h and k, are present in the function, the parent function is translated both horizontally and vertically. So here we have our parent function, f of x equals x squared. That's represented by the black parabola on the graph. Now let's take a look at the red. G of x equals x minus 3 squared plus 2. So what happened with this one? Well, it went over 3 to the right and then vertically up 2. So let's take a closer look at this. So we have g of x equals x minus 3 squared plus 2. So this plus 2 is represented as the k in our vertical translations. So that's why it went up 2. And I'll just start at the vertex, 1, 2. And now we had this x minus 3. So again, this is our h. And we'll review that because this could get a little tricky. X minus h squared. So it's really x minus something squared. Well, what do I have to put in right here so it looks exactly like this? I have to put in a positive 3. So even though you see like minus 3, you want to think about it as minus positive 3. And since it's positive, okay, we're going to translate it 3 units to the right. Okay, the last one we want to look at is h of x equals x plus 3 in parentheses minus 1. So we have h of x equals x plus 3 minus 1. So the minus 1, that is our k. So I'm going to start right here at the parent function. And since it's minus 1, that's our vertical translation. So it went down 1. Now we want to look at our h. So again, we have x plus 3 squared. So let's break this down a little bit. So we have x minus h squared. And this becomes x minus something squared. Well, what do I have to put in right here so it looks exactly like this, which is plus 3? Well, subtracting a negative is the same thing as adding a positive, so it's minus 3. Okay? And it's good to see it as not just plus 3, but plus minus negative 3. Okay? Because subtracting a negative, same thing as adding a positive. And if we were just to take a look at the graph, okay, this again would move 1, 2, 3 spaces to the left because this is really negative 3. If you have any questions, please send me an email, and thank you for watching this video.